Hi all, welcome to myclass.com. In this lesson, we are going to discuss about the data structure tree. Tree data structure, a non-linear hierarchical data structure. In the previous videos, we were discussed about the data structure like array, linked list, stack, queue, etc. All are linear data structure. Now, we are going to discuss about the non-linear data structure tree. There are mainly two nonlinear data structure, tree and graph. Okay, so first we are going to discuss about tree. The tree is a nonlinear and a hierarchical data structure consisting of a collection of nodes. In this nodes, the informations are storing collection of nodes such that each node of the tree stores a value and a list of reference to other nodes. So a tree contains like node structure. It is like the node structure, like this, a hierarchical structure. Like say there is a branches of tree. Like that, trees looks like this. In each node we are storing a particular value and also there is a reference to the other nodes. What is the connection to the other nodes? That is also holding each node's information. Okay, so let's discuss about all the terminologies based on our tree data structure. Let's discuss about first path. Path refers to the sequence of nodes along the edges of a tree. So what is the edges? Edges means there is a connection. If there is a connection between two nodes, then this line we can call it as edge. Okay. So this is the edge. Then path. What is path? Path refers to the sequence of nodes along the edges. When we can say that, so we have already said that the tree consisting of nodes. This round shaped things we can call it as nodes. In this nodes, the informations are storing. This information we can call it as keys. So the information in all our nodes we can call it as keys, and also each node consisting of the reference to the other nodes. Okay. So first we are looking to the path. So what is path? These all are nodes. C, P, Q, R, A, B, C, D. All are nodes of this particular tree. In this nodes, let's see, if P and A, there is a connection to P and A through Q. See? So, when we want to travel to A, we can start from P to Q to A. So, this is the one path from P to A. In tree, always only one path to a particular node. Only one path between two nodes. If more than one path is available, then that is not a tree. It will become a graph that we will discuss later. So this sequence of nodes, see, what is the path to reach I? P, R, C, M, I. So this sequence we can call it as path. Okay, P, R, C, M, I. Now, one of the main important term, root. So what is the root? Every tree is starting from a one node, that is root. So there is always a one root for every tree, only one root. The node at the top of the tree is called root. In this particular example, P is the root. There is only one root per tree and one path from root node to any node. From root, only one path to any node. See, when we want to reach B, only one path is here. So that is the root of a tree. Fine. Then parent. Any node except the root node has one edge upward to a node called parent. I have already told that tree is a hierarchical structure. Like there is a hierarchical structure, not a linear relationship between nodes. It is a hierarchical relationship in between the elements. So there is a parent-child relationship when compared to the root node. If root node, see, in this particular example, this node has two children, Q and R. So when we are looking to a node R and there is an upward edge to any another node, and any has one edge upward to a node called parent. P is the parent of R. Always remember that P does not have any parent, but because P is at the top of the tree. P is at the top level of the tree. P does not have any parent. Clear? So then the child. What is the child? Child means the node below a given node connected by its edge downward is called its child node. When we are looking to a node and there is an edge downward, see, there is an edge downward to R. So that means R is the child of P and also P is the parent of R. There is a child-parent relationship. Clear? So when we are looking to P, when we are considering the root node P has two children Q and R. This Q we can call it as this is the left child of P and this is right child. Then another term is leaf. The leaf means the node which does not have any child node is called the leaf node. When we are checking any node, if there is no downward arrow from that node, see, B does not have any child. See, does not have any child. So such node we can call it as it is a leaf node. Clear? So this is the root node. And what is path? Path refers to the sequence of node along the edges of a tree, and always there is a parent-child relationship between nodes. P does not have any parent, but P has two children Q and R. And there are leaf nodes in the tree. Leaf node means the node does not have any child node is called a leaf node. Next, another term is subtree. What is subtree? When we are considering a one tree, there should be another tree structure inside that tree. See, in this picture, this is also a subtree. So P's left child is Q. So this is also a left subtree and this is a right subtree. We can call it as left subtree and we can call this as a right subtree. And again we can call this portion also a subtree. So in the subtree, L is the parent and L has three children E, F, G. Inside a tree, we can find lots of subtrees also. So what is visiting? Visiting a node or visiting means visiting tree means visiting refers to the checking the value of a node when control is on the node. When we are traveling or when we are doing something through program, when we are reached here, we can say it as a visiting the node P. Then what is traversing? Traversing means passing through nodes in a specific order. Traversing means lots of nodes are present in a tree. We can arrange this node in a particular order. We can traveling from P, from root node, we are traveling in a particular order. That specific order, there are mainly three orders are the pre-order, post-order and in-order that we can discuss later. So that is traversing. Then the next is level or height. That is very important. Level of a node represents the generation of nodes. See, when there is a parent-child relationship. In our family also generations are there. Our parent generations and our grandparent generations, like that there are generations in the tree also. So in the level means there are two considerations are there. If the root node is at when we are saying that the root node is at the level 0, so there are another levels. The root node has two children, so this is the another level. So this level is 1. Then another in Q also two children, here R is also two children. These are the grandchildren of P. So this level we can call it as it is the second level. Then another is this is third level and this is fourth level. This is the level concept when we are considering root is at the level 0. We can also consider like root is at the level 1. Then root is our level and so this level is at level 2. Then this is 3, 4, 5. Like that we can also represent the level of a tree. But normally we are starting from 0. Height of a tree. It is level and height is a similar concept, and so then we can say that the height in this height of a tree, height of this tree is how much? 4 is height of this tree. See, 4 is height of this tree. How we can find the height of a tree? See, when we are starting from a root node to the last level, how many levels are there? So what is height of a tree? Height of a tree means it is very easy that when we are finding a very longest path in a particular tree. Say here, this is the very longest. So when we are considering P to I, there is the longest path. Is it? Also, this is our longest path. P to Q, A, L, E. This is the longest path. So number of the edges in the longest path is the height of a tree. We can easily understood like this. So here 1, 2, 3, 4. 4 is the height of this tree. We can also find like, see, this is level 0 and this is level 1. So there is a one edge between this. This is the second level. There is also one edge between this. This is the third level. So again one edge, and this is the fourth level. Again one edge. So 4 is the height of this tree. When we are starting from 0, the last level is the height of this tree. Understood? That is all the basic terms we are using when we are telling about the tree data structure. Now we are going to discuss about binary tree. See, this is also a tree. So what is a binary tree? So in this particular tree, P has 2 children, Q has 2 children, R has 2 children, C, D, L has 3 children. Okay, no problem. It is possible. And M has 2 children. D has no children, B has also no children. So this is also a tree. So what is binary tree? Binary tree means it is also a tree data structure. Binary tree is a specific data structure used for data storage purpose. A binary tree has a special condition that each node can have a maximum of 2 children. The main condition is the number of children. A binary tree, when we are looking to a particular node, that each node can have a maximum of 2 children. A node can have 0 child, 1 child or 2 children. So that is the condition of a binary tree. In this case, see, 1 is the root of this node. The 1 has how many children? 2 children, 2 and 3. Every node should satisfy this condition. When we are looking to 2 has also 2 children, 5 and 6. 3 also no children, 0 children. If 3 has 1 child like 7, it is also it is a binary tree. If 3 has 3 children, then it violates the condition of a binary tree. It is a tree, but it is not a binary tree. Clear? So what is binary search tree? So binary search tree means it is also a binary tree. So should satisfy the condition that the node contains only, each node can have only 0, 1 or 2 children. Okay, and another condition is that there is a special behavior. A node's left child must have a value less than its parent's value, and the node's right child must have a value greater than its parent value. See, when we are considering the root node 8 has 2 children, 3 and 10. 3 is the left child and 10 is the right child. Okay, so 3 should be less than 8, and also left child should be less than 8 and right child have the value that is greater than 8. Okay, so when we are considering 3, left child 1 is less than 3 and right child 6 is greater than 3. So all these nodes satisfy this condition, and it is also a binary tree. Then we can call it as a binary search tree. Then after that, we are always discussing about the binary tree and the binary search tree. So the main difference is only the value difference, is the difference in between the binary tree and binary search tree. Let's back to the binary tree. Now we are always saying that, so this is the basic concept of tree data structure. So what is the main purpose of data structure? Storing the value in a organized manner in our computer memory. So that there are two main memory representation of the binary tree. Okay, main representation of binary tree, that is array representation and linked list representation. Now we are discussing about the array representation. The array representation means we are storing the value of keys of each node in an array. Okay, there are two ways of array representation. That is, first way is if we are starting from the 0th index of the array. That is, if the root node is at the index 0, then the left child is 2 star parent plus 1. That is 2 into index of the parent, that is 0 plus 1. So the left child should be at the location index 1. Okay, and the right child is 2 into index of the parent 0 plus 2. That is in the index value 2. So the right child is at the index 1 and the left child is at the index 2. Okay. Now we are going to check the children of the next value, next index, that is 2. 2 has 2 children, 5 and 6. So 2 into index of the 2 is 1. 1 plus 1, that is 3. And also 2 into 1 plus 2, that is 4. So the 5 and 6 should be saved in the index of 3. 5 should be in the index 3 and 6 should be in the index 4. Okay. Now we are going to check 3. 3 does not have any child, then no problem. Now 5, then 5 also does not have any child, and 6 also does not have any child. Okay. So that is the array representation of binary tree. Now another case is that if we are starting from one index 1, if the root node is at the index 1, our equation is little different, that is left child in 2 into parent and right child is 2 into parent plus 1. Only that is the difference. The 1 is at the location 1, then left child is at the location 2 into 1 and right child is at the location 2 into 1 plus 1. So that is 2 and 3. So our 2 is at the location 2 and 3 is at the location 3. When we are going to the children of 2, in the case of 2, left child is 2 into 2 and right child is at 2 into 2 plus 1, that is 4 and 5. 5, 6. So that is the difference between there is a little difference between the two different ways of array representation. Most of the time we are using the first method. So that is the array representation. Then we are going to the linked list representation. So linked list representation, the root node address, if the root node address is 1000, so that is in a pointer our first list of our linked list. Okay, so in this first node our root node should be set. So 1 is here, and also like our double linked list, there is a 2 pointers for our left child and also for our right child. So this is our another memory space for store. So maybe it is 200 and this is 225 address of this node. So the 200 should be here and 225 should be here. Okay, so this is the pointer to the left child and this is the pointer to the right child. Then node, our key value should be in here. So in this each node, 1 info part is there and 2 link part is there. Okay, in each linked list node. So the address value of this node is 301 and then 302. Then this node contains the 301 here and 302 here because there is a pointer to the left child and pointer to the right child. This is how why 5 and 6 should be here. Then if 5 does not have any left child, so does not have any left child, so there is a null value, and here also null value, here also null value, and there is a here also a null value. Then the right child of our root node 1 is 3 and 3 does not have any child, so null values here. So this is the linked list representation of binary tree, and the binary search tree also represent like this because binary search tree is also a binary tree. So that is all about the basics of a tree data structure. Thank you. We'll meet at the next lesson.